Good morning, good morning, good morning. This is your Captain Shreyas. Welcome to the PYQs series. And today we are going to do questions on current electricity and capacitors. So, really amazing top 11 questions. Get ready, guys. It's morning 6 o'clock. It's time for your Captain Shreyas to be here, right? So, welcome aboard. And I hope everybody is watching every single class and not even missing one of it. Even if you miss it, please watch it then and there itself as a recorded class. Okay, because these questions are really good, and even if you might have solved some of these questions before very long time back, it's a good revision and a good habit for all of you to wake up strictly at 6 o'clock and make sure that your rest of the day starts with a fresh mind practicing problems. So that was the main intention of the series, so that you develop a habit and solve questions, and you get a lot of time during the day, or else you'll wake up at 8 o'clock or 9 o'clock. Good morning, BD Harni, Kalyani, welcome aboard. Good morning, Siva, Santosh, Sabrinath, Kalyani, welcome, 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 welcome. Hi, Henry. Hi, everyone. Nice to see all of you. Okay, so looks like everybody is ready. It's time to start the class. And yes, do not forget to subscribe to the Vedantu JEE English channel. And as you're watching this particular video, make sure that you check out the description box later on for downloading the PDF of this particular class. Okay, it will be over here. And yes, make sure you're liking this video, guys. What are you guys doing? Come on, smash the like button right away, right now. Okay, so let's begin and start the lecture. Okay, and Vedya will be also able to help you with your doubts, with your PDF, with smart quizzes, smart notes, everything from this class. So the link will be there in the description box of this same video right over here after the session is over. Okay, cool. So let's begin, and here comes the first question on your screen. Find the current in the 2 ohm resistance if 10 amperes of current is entering point A in this particular circuit. Looks like a crazy circuit, but whenever you see this kind of question, this is a standard model where it can be rearranged to be seen as not a parallel, not a series, rather a Wheatstone's bridge. Yes, you might be wondering how, but yeah, it is actually a Wheatstone's bridge, guys. So if you take this particular point A, from A there are two branches, 2 ohms and 3 ohms. Okay, so you have 2 ohms and you also have 3 ohms over here. That 3 ohms and 2 ohms are connected on the other side by 5 ohm resistance. So just show a 5 ohm resistance right over here. And from those 2 points, you have 4 ohms and 6 ohms. You have 4 ohm and you have 6 ohms, which are joining back at that particular point B. So this is 4 ohm and this is 6 ohms. Now you can see this is nothing but a balanced Wheatstone. This is nothing but a balanced Wheatstone bridge, because 2 by 4 and 3 by 6, 1:2 ratio is there. So whenever you have a balanced Wheatstone, the resistance which comes in between can be completely ignored. So this 5 ohm resistance can be ignored completely. So 2 ohms and 4 ohms basically become together how many ohms? 2 plus 4 is 6. So basically from point A, you're going to have a 6 ohm resistance. 3 and 6 will make a 9 ohms. So there you go, something like this. This will be 9 ohms. Yeah, this is your point A, this is your point B. And it is mentioned to us that over here 10 amperes of current will enter. Now these two basically are in parallel. You don't have to find equivalent resistance. I'll tell you why. Because the current will get divided in the inverse ratio of the resistance. So if this is I1 and if this is I2, then the ratio of I2 by I1 will be R1 by R2, basically 6 by 9. This is since current will get divided inversely to the resistance in a parallel circuit. That is the concept behind it. Okay, so inversely it will get divided. I2 by I1 will be R1 by R2. I2 will be proportional to 6 and I1 will be proportional to 9 inversely. So 6 by 9 is nothing but 2 divided by 3. This is nothing but your I2 divided by I1. I have an idea now because I wanted to find I1, right? Because this same current I1 will be flowing over here like this. Remember, no current will flow through the red 5 ohm resistance. This will be I2. And this is exactly what has been asked. How much is basically this particular I1? That is the question. So use componendo. Remember componendo? So numerator plus denominator divided by denominator will be numerator plus denominator divided by denominator. So what do we really get? I2 plus I1 is basically the total current, which is nothing but 10 amperes, divided by I1 is 2 plus 3, which is 5, divided by 3. Therefore, I1 will be 3 multiplied by 10 divided by 5. So this is nothing but 2 and 2 threes are nothing but 6. So I1 will be nothing but 6 amperes. I think printing mistake is there. But yeah, the correct answer would be nothing but 6 amperes. Okay. So I just change one of the options over here. Yeah, this should have been 6 amperes. And that would be the correct answer. Is that clear, guys? Everybody with me? Yeah. How do we solve it? We first have used the concept that this is actually a disguised form and the actual circuit is a Wheatstone's bridge. Then we checked it is balanced, so no current will flow here. Then we converted it into a series parallel problem. Then we saw current will be inversely related to the resistance, and then mathematics of componendo also came into play, which simplified the question, and I did not actually find the total resistance, which will unnecessarily increase the length of the problem. This was much simpler and the easiest method. 6 amperes. Yeah. For 5 ohms, if the question was asked, then what will be the answer? Answer it in the chat box. If it was 5 ohm resistance, what would be the current in that 5 ohm? You can see it is in the middle of the bridge where null deflection will occur. So actually no current will pass. Then the answer would be 0 amperes. Okay, that is the manner in which you can solve this. Next one, a silver wire of some radius and some current has a charge density of so and so. What is the drift velocity? I remember a formula. Drift velocity, current, area. There are multiple formulas like E by M into tau, which is on relaxation time. But relaxation time is not given. So we can use current is equal to NVIDIA. Current is equal to NVIDIA. Remember this? Yeah. Yeah. Yes. Which is a componendo and dividendo method. Yes, yes, yes. But I am not using componendo and dividendo. I am using only componendo. So when I use only componendo, only the numerator and denominator will get added. Subtraction will not happen in the denominator. Denominator stays as it is. If it is only dividendo, there will be only subtraction in the numerator. And when you do both, addition in numerator and subtraction in denominator. Okay, so those are those three properties. Yeah. So current is NVIDIA. So therefore, drift speed will be current divided by NE area. Area will be nothing but pi r square. So it's just about substituting it. Current will be 2 amperes. This is basically your N, guys, number of charges per unit volume. So it will be 5.86 into 10 to the power 28 electron charge. Electron charge, my god, this is going to get crazy. 1.6 10 to the power minus 19 multiplied by pi value, which is 22 by 7 also you can write. Okay. And finally, r square, radius is 0.1 centimeter, meaning 10 to the power minus 3 meters. So 10 to the power minus 3 meters, but square it because r square is there. So you just have to do this, guys. I mean, couple of things simply will just go off, like this will become 11. Okay. Now 5.86, 1.6. Come on, guys. Just do the approximate mathematics and tell me what answer roughly are you getting? Come on, quickly, guys, in the chat box. Approximately what answer are you getting? Come on. Approximately, guys. Approximately what answer are you getting after solving this? C option says Sabri, Pakka, everyone. Chalo, come on, think about it. Yep. How much answer approximately are you guys getting? Let me know in the chat box. Yeah. Today is your practice day, guys. You have to do it. Hmm. Do the math approximately and see how much are you getting. Because if you think about it, 5.86 and 1.6, if you multiply this, it will be a number which is more than 7, more like 8 or 9 or something. And if you multiply this 11 with that number like 8 or 9, will be close to 90 or 99 and stuff like that. So this will be 1 by 100 approximately, close enough to that. Yeah, just check. So check if you are getting close to 0.68 into 10 to the power minus 4 approximately. Yeah, just try this out, everyone. All right, option C. Very good. Many of you got it. No, Santosh, it is not option D, it is option C. Okay. So sometimes you might also have some calculation questions, and every day, guys, it's good to solve some calculations in the morning. It freshens up your mind. Even if you are doing 1 plus 1 is equal to 2, it's okay, but do that mathematics in the morning. It's going to freshen up your mind. All right. Moving on to the next question on your screen. The charge is flowing inside a conductor given by this equation. This equation is telling me that with the time the charge flowing is changing. The question is, what's the minimum value of the current in this particular circuit? Minimum function, clearly maxima minima concept is used over here. So if charge is given, we can find out the current. We can find out how much current is flowing in the circuit by taking the derivative of it. So you just have to take dq by dt. So basically alpha into derivative of t with respect to t minus beta into derivative of t square with respect to t plus gamma into derivative of t cube with respect to basically t. So what do I get? Current as, this will be alpha, derivative of t will be 1, beta into this will be 2 beta t plus this will be 3 gamma t square. That's the current. But whenever you have to find minima and maxima of a function, then you take basically the derivative and equate it to 0. So for minimum value, the di by dt will be 0. So take the derivative of this. So derivative of alpha with respect to time minus 2 beta into derivative of t with respect to time plus 3 gamma into derivative of t square with respect to time should be 0. Constant's derivative is 0. This will be nothing but just minus 2 beta into 1. This will be nothing but 3 gamma into 2t will be 0. Take this on the other side. So 3 2s are 6. So 6 gamma t is equal to 2 times of beta. Therefore, time will be 2 and 6 cancel. So it will become beta divided by 3 gamma. This time you will see that the current is going to be minimum. You can check the second derivative also. but that will be unnecessary waste of time. When they have told it is minima, just take. If you have got two values, then I will check which one is minima, maxima. If I'm getting one value, don't waste your time in the exam for checking second derivative. Is that right? Good morning. Good morning. Vedh1001. Yes, Sanjay Kumar. Good morning. Good morning, everyone. So, which part you did not understand, just let me know and I will help you with that. Once you get this, substitute this in this equation back over here. So, wherever you see time, just substitute it back and you are going to get the answer. Therefore, I is equal to alpha minus 2 beta. Instead of time, you are going to put beta divided by 3 gamma plus 3 gamma into what is it? Beta square divided by 9 gamma square. So what do I get my value of the current as? Alpha minus, so this is 2 by 3 beta square by gamma plus 3 and 9 cancel. So 1 by 3 beta square, again gamma will cancel by gamma. 2 plus 1 is 3, 3 by 3 is 1. So it will become alpha minus beta square by gamma. That is the value of the minimum current. So alpha minus beta square by, did we make any mistake over here till now? Just check it out. Everything is fine. Alpha minus beta square by gamma. Did we miss out anything? Just check it out. Beta square by 3. Oh, yes, I know what mistake we made. I remember. Yes, guys, this is minus and this is plus. I added both of them by mistake. Yeah, this is minus 2 by 3 plus 1 by 3. Yeah, so this will become minus 1 by 3. So this will become minus 1 by 3 and beta square divided by gamma. So therefore, this will become I is equal to alpha minus beta square by 3 gamma, which is the fourth option. Let's check. Yes, it is absolutely correct. Amazing. Very good, very good, very good. Okay. The 3 should be there in the denominator and our problem is done. So some maxima minima charge based questions can also come. Usually I have seen these derivatives and integration questions come. The reverse question can also come where current is given and they ask you the charge flowing through it. You open up, many PYQs will be there. So derivative or integration on dq by dt can come in your JEE Mains examination. This is a very probable question. Next one on your screen. In a meter bridge experiment, the balance point is obtained if the gaps are close by 2 ohms and 3 ohms. A shunt is added, then the null point will shift by this much. The value of the shunt is how much? Okay, let's analyze the question. There are two parts, I believe, in this particular question. In the first part, in the meter bridge experiment, what has happened is you have those gaps which are there inside that meter bridge experiment. This is your potentiometer wire like this, and this is your battery and all of that like this. Now, in this particular gap, you have put how many ohms? 2 ohms. In this gap, right gap, you have put 3 ohms and you will get some null point. Now, first of all, let's figure out how much that null point will be, then we will go ahead. See guys, we all know if this is L, this will be 100 minus L centimeters and the formula is R1 by R2 will be first length by the second length, 100 minus L. So cross multiply, this will be 200 minus 2L is equal to 3 times of L. Therefore, 200 will be 3 plus 2 which is 5L. Therefore, L will be nothing but 200 by 5 which is 40 centimeters. So this is the first length initially in the first case. So the balancing point initially is basically 40 centimeters. Now what are we doing is that we are taking that same circuit, but we are shunting the 3 ohms with X ohms. This 3 ohms, we are shunting it by X ohms. But the 2 ohms is remaining as it is. So keep the 2 ohms as it is. And over here, you are having one more parallel resistance that is called as shunt. So this is X ohms, this is 3 ohms, and the rest of the circuit will stay as it is. And just like before, you will have a balancing point and all of that, but the balancing point has been now shifted. Keep that in mind. So this is your potentiometer wire, and now it is somewhere over here like this. So what is the new balancing length? Well, clearly it is mentioned it shifts the null point by 22.5 centimeters. So the new balancing length, the new balancing length will be, the previous one was 40 plus 22.5, which is going to make it 62.5 centimeters. Is that right? So this new balancing length is going to be 62.5 centimeters. So how much will be remaining? That will be 100 minus 62.5, which is how much, guys? That will be 37.5 centimeters. That is what will be remaining on the other side. Now, from this, we can again use our balancing ratios and we can figure out how much the resistance will be. So, 2 divided by whatever is that equivalent resistance in parallel, RP I will call it, will be this divided by this, which is 62.5 divided by 37.5. From this, I will get my value of RP as 2 multiplied by 37.5 divided by 62.5. Yeah, is that right? Everybody with me? So 2 into 37.5, guys. Yeah, 37 twos are how much? That is going to be 74 and 74. So this will be nothing but 75. Yep, everyone with me? So this will be 75 and 62.5. I can keep it as it is, or if you want, you can write it as the half of 125. We can also write it as the half of 125. Is that right, everyone, till this point? Okay. Now you can do some simple cancellations, like 75 divisible by 25 3 times, 125 divisible by 25, sorry, 5 times, and that number 2 will go on the top. So this will just become nothing but 6 divided by 5. This will nothing but become 6 divided by 5. That is your RP. But I do not want RP. I want, what do I want? I want X. So I have an idea. Take the reciprocal of it. So therefore, 1 by RP will be nothing but 5 divided by 6. Will be nothing but 5 divided by 6. Now, this is equivalent parallel resistance. So use the parallel formula. So 1 by X plus 1 by 3 is nothing but 5 divided by 6. Understood why I took the reciprocal? Everyone, why I took the reciprocal? Awesome. So now just rearrange it, you will get the answer. So this will be 5 by 6 minus 1 by 3, but we can take the LCM. So 6 and there will be 2 over here. So 5 minus 2 is 3. So 3 by 6, which is nothing but 1 by 2. So 1 by X will be 1 by 2. So X will be nothing but 2 ohms. So 2 ohms should be the answer, and absolutely we are correct. So sometimes it can be lengthy, but you can see it is a doable question. It's just that the physics part came only 2 times for writing this part and maybe only for the parallel part. That's it. Apart from that, it was just basic algebra, not even like complex algebra. So, it was a simple problem only, but yeah, lengthy. This comes under simple and lengthy problem. That's all. It will take 2 minutes to 3 minutes of your time maximum. Okay. So first time without any shunt. Shunt means you have connected in parallel. So it has shifted, and rest simple calculations. Okay. Let's go to the next question on your screen, guys. In the given diagram, assuming point A to be at 0 volts and the currents are already marked, find the Kirchhoff's rule to find the potential at point B. Point B is not printed, but this is the point B. What is the potential at point B? That is the question. All right. Now, in order to find the potential at point B, I can start from A, which is given to be at 0 volts, and I can go via some path. And if I go via this particular path, I think my job will be done because, oh, but do I know the current through the 2 ohm resistance? If I know the current through the 2 ohm resistance, then my job is done, or else I will be stuck. Okay, because the logic says that if I start from point A, so the potential at point A, okay, I'm just going along this particular path, guys, like this, like this, like this, okay, and here I'm getting this battery, so I'm going from negative to positive, so plus E or plus voltage, negative to positive. Here I don't know how the current will be, so I need to figure that out. Without that, I cannot do anything. So at this particular junction, at that particular junction, you can see if I apply Kirchhoff's current law, then 2 amperes of current is coming in, and whatever is going out, I will put it over here, that is 1 ampere. So it is not balanced. So 100% extra 1 ampere should be going out of it. So 1 ampere of current will be going like this. That becomes obvious when you use Kirchhoff's current law. So now when I am going like this, for our Kirchhoff's voltage law from point A to point B, I am going through the resistor against the direction of the current, and whenever you go against, the voltage drop is plus IR, not minus IR. So plus current, which is 1, into resistance, which is 2 ohms. Lastly, I'm going through the battery from positive to negative, so this will be basically minus 2, and that finally will make me reach point B. So you can see this particular 2 and this particular 2 is cancelling, so VA plus 1 is VB, but VA is how much? VA is already given to be 0 volts. This is nothing but 0. Therefore, VB will be 1 volt. Hence, this is the correct answer. Everyone with me? Clear? 1 volt? Yes, perfect. Ved, awesome, awesome, awesome. Everybody is getting the right answer. Yes, Amal. Yes, Janash. Very good. Perfect. So you just had to use Kirchhoff's voltage law. That's all. Amazing. Amazing. Let's go to the next question coming up on your screen. Okay. Yeah, there we go. The potential difference across the 4 microfarad capacitor, but which one? This one or this one? I think it will be this one. So not the other one. In the following circuit is how much? Okay, 4 capacitor in parallel with 2 microfarad is how much? That is the question. Okay, so I'll just redraw this particular circuit now, because this requires reduction of the circuit into a simplified capacitor, and then again going back to this true nature. So 9 volt is given. First of all, these two capacitors are in parallel. So what I'm going to do, I'll just convert it into a single capacitor. So what I'm going to get is this 4 microfarad as it is. 4 and 2 in parallel, the capacitors will add. Remember, it's capacitors, not resistors. So just add both of them and you will get how much? 6 microfarad. 4 plus 2 is 6. That's it. And they are basically connected to this 9 volt battery. I'm still not happy. I'll convert it into a single capacitance now, and that will be the final true equivalent capacitance. Right. So this is 9 volt. So how much will be the equivalent capacitance? Because they are in series, it will be C1 C2 by C1 plus C2. So 4 into 6 divided by 4 plus 6 is 24 divided by 4 plus 6 is 10. So divided by 2, that will be nothing but 12 divided by 5. So this will be nothing but 12 divided by 5 microfarad. Is that clear till this point, everybody? Let me know quickly in the chat box. Is that much clear? Okay, very good. Now, what we'll do? Observe. We will try to figure out how much charge is there on this capacitor, because the same charge will be there on both of them. So the charge on this particular capacitor Q will be C into V. So 12 by 5, 12 by 5 into voltage, which is 9. Okay, so 12 by 5 into 9. Now 12 nines are nothing but 108. So it is basically 108 by 5 microcoulomb. Now same 108 by 5 microcoulomb and 108 by 5 microcoulomb will be there on both the capacitors because they are in series. So like I said, when you're solving such questions, you have to reduce the circuit and again go back to the original circuit to figure out how much charge etc. is there. Last thing, this 108 by 5 will still remain over here. 108 by 5 will remain over here, but this 108 by 5 will now get distributed in both these branches. Will now get distributed in both these branches. How to figure out? How to figure that out? But is that the real question over here? That is not the question. The question is actually figure out how much is the voltage difference. So actually the question is slightly easier than figuring out how much charges are there. I know one thing, that in total, both of them will have 108 divided by 5 microcoulomb charge in total. Okay, this is in total, in parallel. But I don't have to figure out the individual charges. The question is find the voltage difference. So in parallel, one more thing happens. Whatever is the voltage drop over here will also be the same voltage drop, across the 6 microfarad. And that voltage, Q is CV. So V is Q divided by C. So it will be nothing but charge divided by capacitance. And the charge over here is nothing but 108 divided by 5. Capacitance is nothing but 6. So do the math and quickly tell me, guys, what is the answer? Yes, come on, do the math and tell me quickly what is the answer. 108 goes divisible by 6. 18 5s are 90, 18 6s are 108. So this will be nothing but 18 divided by 5. So this will be nothing but 3 point, how much? 6 volts. 3.6 volts. Is it there? Sorry, not 3.6. No, 3.6 only. Sorry. 3.6 is not there. Why? I think option is printed in a slightly wrong way, but yeah, it should be 3.6 volts. Yeah, it should not be 3.5 volts. Okay, or 3 point anything else volts. So even if you see the solution over here, yeah, it is 3.6 volts only, guys. So I think there is a printing mistake over here. So we'll just ignore that particular thing. Okay, so it should be 3.6 volts. So if you want, I'll just make one of those options 3.6 volts so that it will look correct. Okay, so this will be 3.6 volts, and that will be the correct answer. That will be the correct answer. Okay, moving on to the next question coming up on your screen. Get ready, guys. Yeah, perfecto, amazing. And guys, if you've forgotten to smash the like button for this session, do that right away, right now. Okay, yes, quickly. Thank you so much. A capacitor of unknown capacity is connected across a battery of V volts. The charge stored in it is Q coulombs. And when the potential across the capacitor is reduced by V1 volts, the charge stored becomes Q1. Okay. The potential V is how much? I think it's just a play of equations and mathematics, little bit of manipulation also. So let's try this out. This capacitor of unknown capacitance is connected across the battery, the charge stored is Q coulombs. So we all know Q is equal to C into V. We will assume the capacitance. We'll assume the capacitance as basically C. We'll assume the capacitance as basically C. Okay, not an issue. Now, in the second scenario, the potential across is reduced by V1. The charge stored in it becomes Q1. So, in the second scenario, Q1 will be the same capacitance, but it will be V minus V1. That is the catch. Many people will make a mistake. They'll put V1 directly. It is reduced by an amount of V1. Please bear that in mind. Now, what we don't want is C, because C is not there in the solution in the given, it's an assumed variable. So it's kind of obvious now what you have to do. Obviously, you have to divide both of them. So if you divide both of them, what do you get? Q divided by Q1 is equal to V divided by V minus V1. Is that right? And the question is find V over here. So it makes sense to just cross multiply first and see what do we really get. So Q into V minus Q into V1 will be Q1 into V. So bring all the terms containing V together. So therefore QV minus Q1V will be Q times V1. So taking V common and shifting other things below, so Q into V1 divided by Q minus Q1. So QV1 by Q minus Q1. QV1 by Q minus Q1. That is option A, of course. That is the right answer. Is that okay? Understood how to solve this? Simple, basic algebraic manipulation was there. But yeah, it is a nice question to solve because it looks little different. Okay, cool. Let's do the next one coming up on your screen, and here it is. 5 capacitors are connected as shown. The ratio of the equivalent capacitance between P and R and between P and Q is how much? Oh, there are two questions in it. So I'll just create a duplicate slide. So if I consider the first scenario where P is the first point and R is the second point, then these two will be in series, correct? These two capacitors will be in series, and these three capacitors also will be in series. And the value of the series combination, two capacitors in series, it will become C by 2. Three capacitors in series, it will become C by 3. Now their combination is in parallel, guys. So basically you have two capacitors now in parallel like this between the points P and R. One is C by 2, the other one is C by 3. So between your P and R, the equivalent capacitance is C by 2 plus C by 3. 3 plus 2 is 5. So 5 by 6 C is the capacitance between PR. Is that okay? That is what I will get. When they are in parallel, you will just add the capacitances. Now do the same thing for the other one. So between the points P and which one they have told? Q. So Q is basically this point. So now you will say that all these people, sorry, not just this, even this, all these are basically in series. And in series, it will be C divided by 4. 1, 2, 3, 4. This one is individual. So now you have from point P a singular capacitor C, and on the other side you have C by 4. You have C by 4. Both of them you can convert it into one single capacitance between P and Q. So that single capacitance between P and Q will be C plus C by 4, which will be 5C by 4. Okay. Now the real question is find the ratio of it. So CPR divided by CPQ will be, CPR was 5C by 6. This was 5C divided by 6. This is 5C divided by 4. So 4 goes on the top, 6 comes below, 5C cancels. So this will be nothing but 2 by 3. So 2 by 3 is nothing but option number B, of course. You can see option B is the right answer. Is that clear? So you should know some simple tricks up your sleeve, meaning if capacitors are equal and they are in series, then the new capacitance will become n times less. If they are in parallel, then it will become n times more, because when they are in series, their capacitance will reduce. When they are in parallel, the capacitance will increase. So very simple things. And then normal series parallel circuit, and you have to take the ratio. Yeah, simple only, not difficult. Yeah, everybody? Very good. Yes, 2:3 is right, correct. Okay. Moving to the next question, guys, on your screen. The capacitor is filled with air and the capacitance is C naught normally. When half of it is filled with a dielectric constant, then the new capacitance will become how much? And what is the ratio of it? Okay. So see how the points are connected. That is very important. If the slab was like this, then the slab and air will be in series, but the manner in which the wires are coming, the terminals are there, you can see the air gap here and here. It's as if this circuit has two capacitors in parallel, guys. Yeah, it has basically two capacitors in parallel. So think of it like this. One wire is coming and it is getting distributed into two parts, and there is one capacitor here. There is one capacitor here, like this. This is your air gap. This is your dielectric slab. Like this. So this is basically the equivalent diagram. Area will be A by 2. This will be A by 2. Okay. So I just converted this into a simple looking circuit. You can see both the capacitors are in parallel. So original capacitance C naught, we can easily write it down. So C naught would be epsilon naught area divided by D when it is completely filled with air. When it is filled with air. But when it happens like this, then each one of them will have a capacitance. Like this one will have epsilon naught A by 2 and into D. Area is divided by 2. Here it will be epsilon naught multiplied by K, and then area is divided by 2 and then D. So the equivalent capacitance of this combination, which will be now Cn, okay, the new capacitance is now called Cn. Just have to add both of them. So epsilon naught K A by 2D plus epsilon naught A divided by 2D. So epsilon naught A divided by 2D is common, and you have K plus 1. That is your Cn. But I know epsilon naught A by D. I know epsilon naught A divided by D right over here is nothing but C naught. So this epsilon naught A and this D is nothing but C naught. I will need the ratio later on. So K plus 1. So take C naught below. So it will become Cn divided by C naught is K plus 1 divided by 2. So K plus 1 divided by 2, that is option A, and there we are done. Amazing. So these kind of questions, you have to be careful how the slab is placed. The way it is placed, right now they are in parallel, but if the slab was like this, then they would be in series. Keep that in mind. Okay. So you should always look at the manner in which the slab has been placed, or else you will get a completely wrong answer. Okay. Moving on, last few questions coming up on your screen, and here it is, guys. Two identical metal plates are given charges Q1 and Q2 respectively. If they are now brought close together to form a parallel plate capacitor, see, the potential difference between the plates is how much? Wow, interesting. We have a plate here and a plate here. This plate has a charge of Q1 and this is basically Q2. Q1 is more, so this is higher potential, you can say. This is higher and this is lower as per the given information only. And now these two plates will have some voltage difference across them. Question is, what is that voltage difference? Interesting. Capacitance is already given. Capacitance is C. Okay, capacitance is C. Very nice question, guys. This is for multiple directions, as in, what do you mean by multiple directions? Multiple directions. You mean something like this? See, if it is like this, like this, like this, and let's say one slab is placed here, and you are saying another slab is placed here, like this, no? K1, K2, and let's say this is air. Then it is a combination of all three. So there will be one capacitor like this. There will be two capacitors over here, like this. This will be K1. This will be K2, and this will be air. This is how it will go. So K2 and air will be in series, and their combination will be in parallel with K1. That's how you are going to do it, if that was your question. Okay, still simple only. Okay, fair enough. Now, how do we do this particular question, guys? Now, we all know Q is equal to CV, but that was okay when the charges were like, Q and minus Q. But here it is Q1 and Q2. So you need to be little bit careful over here. You need to be little bit careful over here. First of all, try to think in electrostatics chapter, if such charges were given, how will the charges get distributed? What will happen first is the total charge, if you see, is Q1 plus Q2. Whole thing divided by 2 will be there on the outermost plates. So on this plate, it will be Q1 plus Q2, whole thing divided by 2. And on this side, it will be negative of Q1 plus Q2, whole thing divided by 2. So that will be there on this side and on this side of the plates. Now, what is there inside? Let's have a look at it. Inside, if you notice, the charge which is in the inner side of the plate facing the other plate will be this charge minus this charge by charge conservation. So it should be Q1 minus Q1 plus Q2 whole thing divided by 2, which is Q1 minus Q1 by 2 is Q1 by 2. So it will become Q1 minus Q2 whole thing divided by 2. That is what the charge will be. And same thing if you do it over here, okay, it will be Q2 minus of that negative charge of Q1 plus Q2 whole thing divided by 2, right? So you can do the math and see how much is it coming out to be. Q2 minus of this particular thing. Is that right? Just check it out. We just subtracted these two things. Okay, Q1 minus Q2. And over here, actually, I don't even have to do this. I'll tell you what, whenever you use Gauss's law, and you solve these plate problems, whatever charge comes on this side of the inner plate, the exact negative charge comes on the opposite side. So on the opposite side, the charge will be negative of Q1 minus Q2 whole thing divided by 2, isn't it? You would have noticed this when you solve those plate problems. Inner surfaces always develop opposite charges. Now, this is the charge which you should consider for the capacitor's charge. Outside charge is never considered. So, outside charge doesn't or doesn't matter, I would say, doesn't matter for considering the capacitance, because the capacitance is between the plates of the two capacitors. So guys, the electric field which is there, it will be over here, which is going to store the energy. So the inside charge is what matters. So when I say Q is equal to C into V, this Q is always the inside charge, never the outside charge. So it will be nothing but Q1 minus Q2 divided by 2 is CV. So V is equal to Q1 minus Q2 whole thing divided by 2C. That is the answer. Is that clear, everyone? So directly you are saying Q1 minus Q2 divided by 2C, which is C option. Perfect. So lot of students do not know this by 2 will come. They will just write down Q1 minus Q2 by C, which is the first option. Or sometimes they add the charge Q1 plus Q2 by C, and every time you will get a negative mark. Got it? Yeah. Many students usually make that particular mistake. Okay. So whenever you see such plate problems, remember the charges though first of all will get distributed equally outside, and then you will see the inner plates will develop some opposite charges, and you can use basically your charge conservation. Right. Perfect. Okay. By mistakenly, I have put negative charge over here, guys. This was not negative. This was positive only. By mistake, I put negative. This was the total charge which will be distributed equally. Q1 plus Q2 by 2. Q1 plus Q2 divided by 2 equally will get distributed outside, not negatively. By mistake, I had put that minus sign. I'm just correcting it. Okay. Now, going to the next question. And I think, yeah, it is the last question also. Two capacitors, 100 microfarad and 50 microfarad, are connected in parallel. Okay. The potential difference is 20 across the 100 microfarad, and across 50 microfarad is 40, then the common potential of the parallel combination will be how much? Same polarities of the capacitor connected together. So what it means is, initially 100 microfarad had this much voltage, 50 microfarad had this much voltage. So if you take our 100 microfarad capacitor, it had a voltage of 20 volts. And if you take the 50 microfarad capacitor, if you take the 50 microfarad capacitor, it had how much volts? It had 40 volts. Okay. Now you take both of them and you connect them together in parallel, basically, something like this. Okay. So this is your 100 microfarad and this is your 50 microfarad. You connect them together. Question is, what is the common potential of the parallel combination if same polarities are connected together? Okay. First of all, when 150 are in parallel, I can convert this into a simpler circuit. Parallel means you can just add the capacitances. So this will become 150 microfarad. 150 microfarad. Okay. Now I'll go back over here and I will think how much will be the charge on this and this. Q is CV. So this charge on 100 will be 100 into 20, 100 into 20, which is nothing but 2000 microcoulomb. Is that right? 100 into 20 will be 2000 microcoulomb. On this, it will be 50 into 40. 50 into 4, 200. Again, one with 0. So again, it comes out coincidentally 2000 microcoulomb. Oh, now what will happen when you connect these capacitors together? The charges will get realigned to maintain potential difference. It's not that, sir, the charges are same, so no charge will flow. Wrong. The charges will get distributed on these plates. So positive, negative, positive, negative. But keep in mind the total charge will be conserved. The total charge is going to be conserved. And what is the total charge? It will be 2000 plus 2000, which is 4000 microcoulomb. So this common equivalent capacitor will have 4000 microcoulomb. Once I get it, we can find the voltage now. Yeah, we can easily find the voltage because Q is equal to C into V. Therefore, voltage will be charge by capacitance. How much is the charge? The charge was 4000 microcoulomb. And what is the capacitance? That is 150 microfarad. micro will cancel, 0 will cancel. So it will become 400 divided by 15. Yeah, 15 by 5 is 3. 400 divided by 5 is nothing but 80. So it will be 80 by 3 volts. 80 by 3 volts, which is the D option, which is nothing but your D option. Absolutely correct. What a brilliant question, guys. Yeah, I hope you loved it. So whenever such questions come where you take two charged capacitors or one charged, one uncharged, and you connect them together, at the end of the day, it is one simple parallel capacitor. So don't solve this problem, always solve this problem. And remember, the total charge will remain conserved. Now here, the polarities were similar, but imagine a question where opposite polarities were connected, then also total charge will be conserved. But the problem will be positive is connected to negative, negative is connected to positive. So it will not be 2000 plus 2000, it will be 2000 plus negative 2000. So in that case, 0 coulomb would have come, just if that would have happened. Getting my point? So positive connected to negative, positive charge and negative charge together will make, if they are equal, then it will make 0 charge. So be careful with which polarities are connected together, else you will get a completely wrong answer. So that was the last question, guys. And guys, remember, Ved is there to help you out in every problem that you have. And Ved subscription right now is absolutely free. So check out the link which is there in the description box. Ask yourself some questions and then ask Ved. Ved will help you out with those doubts, whatever you got. PDF also will be available in the description box by asking Ved after some time. Okay. So thank you so much, guys, and keep attending, keep liking the session, keep watching these classes. Your attendance is mandatory because only students who attend these classes regularly, I can vouch for them that they will be at a next pedestal. Okay, you will see the difference between those kids who are not doing anything or sleeping. Your sleep will not give you marks, your actions will give you marks. And if you are not ready to act, Shreyas Sir is pushing you. I am waking up for you. Or else I have no need. I can wake up aramse and I can conduct the class at 1 o'clock also. I will still get, in fact, more views. Why am I doing it in the morning? Because I want to develop the habit. Okay. So thank you so much, guys. This was your Captain Shreyas. Do not forget to like this video and subscribe to the channel. Bye bye. Take care. Thank you.